repairing your infrastructure. You've got a lot of areas that might be problems. Your computing device configuration, you might not know how all your routers and firewalls and everything are set up, and you might not have proper documentation of your network. This is very common. And you should have network segmentation and access control, which we talked about last time with the Splunk project. You should have traffic controls so as your server cannot make an outgoing TCP connection. So you cannot take it over and make a call back home. So attackers will look through your network for the most vulnerable system, and this will often be one that you don't think of as important, like an old backup system that's running or a neglected one that's not patched. So first you have to inventory all your systems, and then you have to improve them. There are host hardening guides. There's quite a lot of them out there with recommended ways to protect systems, recommended settings. Microsoft and many other companies put them out. So asset management, you need to know about all your hardware software assets. So the dates, where it owns, physical location, who's in charge of it, and the network configuration. This would help a lot. This is why I used to do a lot of security audits at colleges, just from the outside, and warn them like a white hatting. And most colleges are a total mess. I remember I notified people at UC Berkeley about things and said, yeah, we know there's all sorts of horrible stuff on the network. The problem is all the teachers are doing weird research, and we can't block anything. See, we even saw obvious botnet traffic and tried to block it, and then the guy said, hey, that was me. I was setting up a botnet for research. And they're like, how am I supposed to secure a network like this? But that's the problem. When you have crazy people doing crazy research everywhere, then you can't really tell good traffic from bad traffic anymore.
And you?
Yeah.
Open up the network all the time?
That's true. That's true. I'm doing the same thing. You're right. Anyway, all right. I'm totally one of those crazy guys doing crazy things. All right, so you got to list your operating systems and your hardware, your network devices, have a network diagram. Yep. Universities, if they're interesting, they got a lot of crazy things going on. Your security software, your endpoint applications, your business applications, you got to have all these things inventoried. And these days, also just for software licensing, how many copies of Microsoft Server and Office and everything am I running? Then, of course, there's the huge problem of passwords. Boy, I went to some talks at B-Sides, Las Vegas with Passwords Con, and the average person, he said, has something like 150 passwords. It's crazy. I think we all know. We might have gotten used to it. Hopefully you've gotten used to using a password manager. The only two choices are to use the same password everywhere or to use a password manager, and the password manager is much better. But anyway, this is crazy. They're everywhere, and you can steal them all kinds of ways. And there's a whole bunch of automatic processes where one server goes to another server to get things like email or logs or something. And so there are internal accounts not used by humans that also have passwords that are used from one computer to call another. And those have passwords that almost never get changed. Those are called the service accounts. And they're often hard-coded and never changed. And bad guys love to compromise them and then launch processes on that account. And they will often be totally missed by people scanning the system.
What's a good example of that?
Domain controllers have a bunch of them. I'm not sure I know the names of them anymore, but you'll see them if. But just background, something called the Background Intelligent Transfer Service. There's a whole bunch of them. A Windows domain controller has a whole bunch of signals coming from other machines. Like to log in, you have to turn on. You have to open like 8 ports in the domain controller just to make it work. There's file sharing, and there's a whole bunch of other things involved in a domain login. And those things are running in the background. So and also backups are another big one, moving your backup data somewhere else. In order to, anything that fetches data from a system has to somehow log in to do that. And there's an account for that. And you'll see them on Windows machines. If you look at the accounts, there's a local system account, there's a local service account, there's a network service account, and so on. On domain controllers, there's a bunch more. These accounts that are not intended for human use. Anyway, so another problem I mentioned before is until recently, people would use Ghost instead of Swarm, and probably some people still do, and that means all their machines are from the same Ghost image, so they all have the same hard-coded local administrator password on every machine. Now, there's a product called Swarm to prevent that, where it customizes each one, but unless you do that, then every machine has the same root administrator password, and you can find the hash on every machine, and once you have it, you now have a local administrator on every machine you can touch. You had a question there?
I just wanted to comment that a lot of the identity and access management seems to be moving from passwords to biometrics, and I don't really feel comfortable with that.
Yeah, people are moving to biometrics, but of course it's not a silver bullet. I mean, one problem with biometrics is you can't change them if they get compromised, and people can compromise them by just taking your fingerprint off a glass or something. So, you know, the best thing about biometrics is to have two-factor, where you have biometric plus a password. That would be better. But yeah,
You heard the two Chinese guys in China, they use a live camera to capture image to get your facial to check, right?
I didn't hear about it, but
So the guy get a good quality pictures and then make it into a movie. So he got a phone and then feed the movie into the camera and then it's like log into everybody.
yeah, I mean, if they were to get a good enough picture of your face, they could just make a model and it would fool the camera. Yeah, that makes sense. Yeah, that's by facial recognition. Now, I know the iPhone's facial recognition is actually shining a laser to get a 3D map of the depth of your face. So you couldn't just use a static picture, but you could make like a model in like a 3D printer or something. That would probably fool it. Or one of those Mission Impossible masks. And there was a news article a couple days ago. They say Google phones will let you in with the wrong fingerprint fairly frequently. They claim it's only 1 in 50,000, but many people are anecdotally saying, my friends can totally get in with the fingerprint. Apparently, it doesn't really measure enough details of the fingerprint.
Fingerprint is only like a couple of points and then they match.
Apparently so. They claim it's enough to make it only 1 in 50,000 that another finger would work, but apparently in practice, it's a lot more than that. Anyway, so here's some service accounts. You'll see the ActiveX installer, app readiness, all these things are running in the background of a Windows machine. And they have log on as a service rights. So they log in and run in the background. Because these come on before you log in. So they're running as services on the operating system. So they log in with special accounts. So then you got software metering, which is keeping track of how many copies of things you're using. Performance monitoring to see if your hard drives or your network cards are getting too busy, your firewalls, your event logs, all these things are instrumentation accounts, and all this data is being moved from one machine to another. And then you can have centralized logging. Like I said, one of the big commercial leaders is Splunk. There are other ones. Some way to get all your data to some central place so you can search it in a central place and track things down. See, not setting passwords on a MySQL server, that's an old one, yeah. In the old days, it was the SA account. The instrumentation accounts, yeah, that's what they call it here. They call this instrumentation is just measuring performance of things. Measuring instrumentation, I think all they mean here is measuring data about your systems. But typically, you do move that data to other systems, and that has to be done with some kind of network login. So I think that's what they mean. Yeah. All right. And so then retention, once you have data, you have to keep it. For example, if you hit credit cards, you are required to keep your logs for a year. And if you are finances, there's other things and all that. So there'll be requirements to retain all this stuff. And so things to log on Windows. Log on and log off are very important. Creation process, creations of users, make the event log storage bigger and forward it all to a central logging system like Splunk. And that's recommendation of elementary log. How good is the ELK stack? The ELK stack, if you use it correctly, ELK stack is Elasticsearch, Logstash, and Kibana. ELK put together is what Security Onion uses, and that approximates Splunk. It's basically the open source version of Splunk, and a lot of people use it and love it, but it is much harder to set up. You have to be more of an expert to set it up. When I taught a class, like I say, it was just miserable. It didn't work very well at all in the old versions. The new versions are supposedly better. So if you want to have the free product, you can use ELK or Elasticsearch. A lot of people do it, and they can make your own central log monitor. If you're willing to pay for luxury, you get Splunk. If you want something in between, there's things like Logarithm, which are cheaper than Splunk, but nicer than ELK.
Splunk inside is Elasticsearch, right?
Splunk what?
Splunk inside is Elasticsearch.
No, I think it's different. I think they made their own custom stuff. Like it does not use standard SQL. They wrote a...
They use Elasticsearch and then they build their...
Yes, that could very well be. It might be actually using Elasticsearch inside. If it's either Elasticsearch or something like it. Yeah. Anyway, so, and on Unix, of course, you keep track of processes and forward all events again. And for applications, you got to keep logs for all your devices and your database, your email, DHCP, DNS queries are really useful, so you know where everybody's going. These are all things you should be collecting and forwarding to your central server. And so your antivirus and host intrusion protection systems, and now they call it endpoint protection systems, these things should all log events to a central server, and you should not let them delete malware. They should instead quarantine it. You don't want to lose that malware because you might have to do malware analysis on it to analyze what the attack is. And don't automatically transmit suspicious files to a vendor that might violate your operational security. You should just keep it in a local quarantine somewhere where you can fetch it and hand it to your malware analysis team. And you have a lot of investigative tools. Access Data Enterprise is FTK's enterprise class system. It can do all sorts of things. The enterprise version of FTK and Encase cost about 100 grand, and then you can like push an agent onto a remote system and harvest it while it's in use. So people won't know. So if you suspect that one of your own employees is betraying you, you can covertly image their system over the network. They won't have any clue, and you'll see what they're doing. And then you can, of course, do that with malware, but they have it built into these tools to do that if you get the enterprise version, and many, many other features. FTK can do that, Encase can do that. They can all do that in the enterprise version, and that's why you pay so much money. You get all these features. So these are, Mandiant will sell you something called Intelligent Response, which I haven't used. I don't really know what it can do. I imagine it's sort of like Velociraptor, but I don't really know. And you can, of course, make your own solution. Just like you could use Elk and pay nothing for your centralized logging, you could have your own investigative tools. You could do it all with open source things like Autopsy and by writing bash scripts and PowerShell scripts to harvest the data. You know, all these tools are not doing anything magic. They're just running scripts using normal languages to harvest data that's there. And you could write your own if you want to. But, you know, at most corporations, it's far better to use a commercial product that's standardized, you know, where you can easily hire employees that are trained to use it and all that. Remember when I started working in a financial agency, I started writing custom scripts, and the boss said, "Oh, no, don't write any code." I said, "What do you mean don't write any code?" He said, "Everything we need is in Office, and you got to use the standard code. If you write custom code," he didn't use these words, but I learned later, you didn't incur technical debt. If you write custom code, then what happens when I leave? Somebody else has to understand it and maintain it. You know, that's a huge burden on the company. It's much better to learn to use the standard commercial stuff when possible, and then it's easy to keep it going.
You can check on you.
What's that?
I can see how that makes sense.
Yeah.
It's cheaper for everybody.
Yeah, I mean, you only write custom stuff if you have to, and when you do, it's an expensive ongoing cost for the company to maintain that custom stuff.
Even though it's more efficient for them.
Yeah, you'd have to make that judgment. Yeah.
No, the financial, they want to double check, so they cannot have one guy do their own thing.
That's also, yes. Yeah, you want to make sure everything you do can easily be reproduced and understood by somebody else. Yeah. All right. So anyway, other things you might do, you should have a patching solution to install the patches on all your devices. And you have two-factor authentication, which we talked about. Password complexity is good. Don't give people local administrative access so they cannot install unauthorized software. Have your firewalls and AVs remove end-of-life systems. Don't leave old things hanging around on the network. Have configuration management, which keeps track of the settings of your routers and switches and firewalls and other devices. Application whitelisting is a very powerful technique, not used that often, but this is where you have a list of approved applications and you cannot put on anything else. This is true at one of my current financial consulting jobs. I have a virtual machine and I can only use the official software they put on there. If you want to put anything else on, you have to ask for permission and get it from the official app store or get special approval. You know, you're not allowed to install anything that is not on the known good list. This is a good practice. It's, of course, much cleaner. It's very annoying if you have developers trying to install software and do research, but it's much better. This means your workers cannot install dodgy, unsafe applications. That's whitelisting, which I think now they're calling allow listing. Allow listing is the better word for that. Anyway, then there are these recommended configurations we saw before, and NSA has some guidance also. And so then there's network segmentation and access control. So instead of just having all your devices connected to the internet, it's a flat network, you break them into segments. You have one segment here for finance and engineering and sales and support and so on, and each one of them is isolated by firewalls, so the traffic has to be filtered to go from one to the next. And now if something bad happens and something like malware starts spreading, it won't get out of this one region. And if you have a DMZ, which is the untrusted network connected to the internet where everybody can see it. So this is likely to get infected, and you have to have barriers. So if an infection starts infecting these machines, there's nothing too important on those machines, and it's difficult for the infection to spread down here. That's what you want. So you have controls. You filter this thing at the regions of the network, and you have proxies to let through the traffic you want, and two-factor authentication to get into the secure places where the important stuff is, like your finance and your development teams and such. There's some of the ports you'll find on Microsoft machines, 135, 789, and 445. This is used for remote procedure calls, which is a big problem in Windows. There's similar process in Unix. This is one process that offers many, many services over the network. And very many of them have typically been insecure, and so most of the famous worms that spread through RPC. And you can do remote administration over those same ports, and you can launch processes remotely, which is what they're for, but that can easily be used to spread malware. So here you've got like an internal diagram showing what's going to happen here. You're going to allow RDP onto this workstation so people can remotely control it. You're going to allow TCP on here, and that's what you should have. You should have a list of what allowed traffic is in and control it all from your firewall, so people cannot, for example, start an RDP on an employee laptop and remote control it from home. They're not authorized. They're only allowed to go to the official place from there. That sort of thing. This is what you should have, and what was missing in that data we were analyzing with Splunk last time, where you were able to make traffic go the wrong way through the network. That's a poorly monitored network, poorly segmented and poorly access controlled network, where you let traffic go the wrong way or to the wrong device. So that's access control. You control the traffic between the zones so people can get what they need, but they can't just do anything. Yeah, RPC is also very difficult to filter in firewalls, yes. Anyway, so for example, the one I mentioned, servers are not allowed to send outbound traffic to the internet. They're just servers. They're not allowed to be clients. And so for system management, administrators should have to go through a designated jump box, and they should have to use two-factor to authenticate there, and then be allowed to go inside. VPN concentrators are often used. They must connect to the VPN with two-factor authentication before they have access to anything internal to make sure that they really prove that they're an authorized user first. All right, and so you disallow traffic between ports on managed switches. This way you cannot share files between one desktop and the other. You put them on the server. This is the way Starbucks is set up now. If you connect to the Starbucks wireless, each customer is in isolation mode. If you do a scan of the network, you will find you're the only computer on the network. The other people in there are all in a separate VLAN, so if somebody has file sharing turned on, you can't get to it. That's what you should have. All right, and then black holes. This is what you do to get rid of default routes. If you have traffic sent to unusual IP addresses, like you have an IP address range for your company and some of them you're not using, so you take all the traffic. One thing people do is take the traffic that's not used and it just gets thrown away, but what's better is to take the traffic to those addresses sent to a system for analysis, because if somebody starts sending traffic to the IP addresses you're not using, they're an attacker. They're not a legitimate customer trying to get to your system. They're scanning your network, so now you know who they are, so that's useful information. You could block their traffic from that IP address or record it. So it's a good idea to monitor the traffic addresses which you should not be getting traffic on and see who's sending traffic to them. Honeypots, some people recommend it. Microsoft has even had patents to sell honeypots to home networks. Honeypots are deliberately vulnerable systems added to attract attackers. Now, they sometimes make sense. For example, antivirus companies run a bunch of deliberately vulnerable machines just to get infected so they can get the viruses. But normally, most people say this is just a waste of time. Setting up deliberately vulnerable machines. Should be a lot better off doing normal, simple maintenance activities like making sure all the passwords, default passwords have been changed, putting on appropriate firewall rules and stuff like that. In general, most people think honeypots are a waste of time. So you gotta have documentation of this stuff, have your network and all your network control points, and you should have a change control board. There should be, if somebody wants to change something like open ports in the firewall, there should be a process where that is considered and approved and recorded, so you know what happened, you know why it happened. And so you've got all sorts of devices that log and monitor your network. Firewalls, intrusion detection systems. You may have full content capture systems that record all the traffic for later analysis. That's expensive. It costs a lot of storage. But if you do have an incident, then you really have a complete record of what happened. NetFlow is simpler. This is where you just keep a summary of what happens. This is what the stream does in Splunk. It just says this address connected to that address for this long, but it doesn't record the whole packets. And then you can have proxy servers which let you access a certain service which it harvests and hands it out from an intermediate point. It's a good way to control access to the internet. So you have DNS and DHCP services. These are really important. DHCP especially, because otherwise your traffic is labeled with an IP address, and if you did not record the DHCP traffic, you don't know which physical device had that IP address at that time. So that's not good. And the DNS is quite useful to record where people are going, where all traffic has been going. So it's a good idea to keep good logs of your DNS traffic, because almost everything goes by domain name, including malicious traffic. All right, 3C. Yeah, CNET 122, yeah, I know about that. I taught that class a few times and added some projects, but I think it's currently taught without any hands-on projects, so yeah. You might want to substitute it with another class. You know, this is an important thing to mention. A lot of students don't know this. If you're trying to get a certificate or degree, you don't have to take exactly the courses that are required. You can substitute other courses. And any 3-unit security course will substitute for any other 3-unit security course. So that's an option. But yeah, I think classes without hands-on labs are very disappointing. You can. There's even a place in the forum. You can say, I substituted this class for that one. One reason it's often done is because the class you need is not offered. Like 124 hasn't been offered in a couple of years. So if you try to get something that requires 124, you could substitute something else, 141, 152, something like that. Yep, 122, you could just substitute it with another class. Yep. The only reason those classes are on the list is because they're the classes we had when we defined those certificates. It's not like it really matters. Anyway. Yep, I mentioned a lot of people don't know this. It's a lot easier to get the certificates and degree around here than you think it is. If you actually have to wait for that specific class to be offered, it can be a problem because, especially now with the budget cuts, it can be a while before a class comes around again. Completed more number of courses required. You can apply for the associate degree, yes. The one thing about the degree is if you try to replace the core courses, they'll give you trouble, like 120 and 106. But the advanced courses you can often substitute. For the degree, I can't do that. That's Claudia De Silva in our department. But you could talk to Claudia De Silva about it and find out. You should be able to apply for the associate degree if you have enough courses. All right. Anyway, let's try this stuff. All right, so which item has a password that's difficult to change? Those are the service accounts. All right. All right, which one of these will destroy evidence? Yep, that's antivirus. It often deletes the viruses it detects, and you probably don't want that. All right, so which log is essential to identify systems from IP addresses? DHCP, of course, that's what protects the connection of MAC address to IP address, which is how you can find out which hardware actually had an address. All right. Which is a dangerous Microsoft feature. I want to be picky. You could say they all are, but anyway. DNS is better than it used to be. The DNS server used to be really bad, but RPC is the one that's most dangerous. All right. Remote procedure call. All right. And which one will reduce the risk from a stolen password? Yep, two-factor authentication, that means you need the password and something else, so if somebody steals the password, they still can't get in. All right. So let's see who won. I don't know who that is. They'll have to tell me their name if they want points, but anyway. Judah, that's your name, I think. And I know who that is. All right. So I got those folks. So let me turn that off and stop the recording. And I saw a question.